All right, so Assalamualaikum and good evening, everyone. So for today's lecture, we are going to continue with Routh Hurwitz Criterion. So yesterday you have learned about Routh Hurwitz Criteria, but for normal cases. And for today, we will go into looking at special cases that happen when you calculate the determinants in the Routh Hurwitz Criteria. So for today, you are going to students will be able to determine system stability using Routh Hurwitz criterion for two special cases. So the first case is when you encounter zero only in the first column. And second one is when you encounter an entire row with zeros. Okay. So let's look at the first case, zero only in the first column. Okay, so there are two cases, zero in the first column and zero in the entire row. Okay, so these are two special cases happen when you calculate the determinants for Routh Hurwitz criterion. All right, so we look at the first case, which is when you encounter zero in the first column. So let's say you are given a trans function as shown here. And then first you need to generate the route table. So first you look at the denominator. So here the denominator is with s to the power 5 as the highest power. So meaning that here you have 5 different poles for the denominator. Or if you solve the denominator here equals 0, when you find the s, there will be 5 values for s, meaning that there are 5 values for the poles. So you know that there are 5 poles, but you don't know the values unless you factorize the denominator. So there are 5 poles, but without factorizing, you can know the system stability. So first you generate the route table, and here you start with s to the power 5. Okay, because you have s to the power 5 as the highest power, and then followed by s to the power 4. So you fill the two top rows with the coefficient of the denominator. So after that, you can calculate the rows S3. Okay. So when you calculate the row S3, you will get 0. Okay. So when you encounter 0 in the first column, you need to do some modification onto the method for the Hurwitz. So the modification that you have to do is you put a small value or a small value with a symbol epsilon. So here I put symbol epsilon to represent a very small values. And then you continue calculate for the other boxes as usual. So you get 7/2 here, 0. And then for the row S2, you get a term which is in terms of epsilon above, okay, this epsilon. And then you continue as usual for S1 also, but you get the value in terms of epsilon, and then continue as usual. Okay, so now you have a symbol here, epsilon, which represent a very small value. So how to determine the system stability? Okay, so first you need to assume that this epsilon, although it's very small value, but it has a positive value. For example, you assume it to be 0.1 or 0.01, for example. And then you try to see whether there are any sign changes in the first column. So here in the first column, if you assume epsilon as positive, so from S5 to S4, there are no sign changes. From S4 to S3, also no sign changes because 2 and epsilon we assume as positive. And then from S3 to S2, so S2 here you need to substitute epsilon with a very small positive value. So you can use, let's say, 0.1, for example. So if you substitute epsilon as 0.1, you will get this term as negative. And then from S1, you also substitute epsilon with 0.1 and you will get positive value. And then you can continue for the rest of the rows. So in the first row, for epsilon to be positive, you will get two sign changes from S3 to S2, one sign change, and from S2 to S1, another sign change. So there are two sign changes. And then you need to repeat the process by assuming epsilon as a negative value, let's say negative 0.1. So you need to put assumption epsilon as a very small value, but negative. So we assume negative 0.1. And then we do the same thing. So from S5 to S4, there are no sign changes. So S3, epsilon now is a negative value. So you put negative. And S2 here, you need to assume epsilon as a negative 0.1, for example. And you substitute and calculate, you will get positive value. S1 also the same. So you put epsilon as negative 0.1 and you get positive. And 3 is also positive. And then you check for the sign changes. So from S4 to S3, there is one sign change. And from S3 to S2, there is another sign change, negative to positive. So also two sign changes. So meaning that this system is has two sign changes, meaning that there are two poles on the right half plane and the system is unstable. Okay. So this is the first method for the case when you encounter 0 in the first column. It might confuse some of you because you need to substitute epsilon with a very small positive or very small negative value. So there is another method, okay? So an alternative method is by first, you can reverse the coefficient of the denominator. So here, the denominator here, you can reverse it. Okay, so you start with, instead of s to the power 5, so you start with 3s to the power 5, followed by 5s power of 4, 6s power of 3, 3s power of 2, 2s plus 1. So you basically reverse the coefficient. And then after you reverse the coefficient, you perform the usual Routh Hurwitz table method, okay? So you substitute the first two rows, S5 and S4, with the coefficient of the denominator, and then you calculate for the rest of the rows. And then you check for the first column. So whenever you reverse the coefficient, then you will see that there is no more 0 in the first column. So it's a lot easier than the first method. So you don't need to assume an epsilon, okay? So here you check for the sign changes in the first column. So you see here from S5 to S2, all of them are positive. And then from S2 to S1, it changes from positive to negative. And then from S1 to S0, from negative to positive. So two sign changes here, meaning that there are two poles. And there are two poles on the right hand side of the S-plane. And the system is unstable and you get the same result as the previous method. Okay. All right. I hope you understand. And if you understand, you can try quiz number 10, question number 1. So if you have any question, just let me know. All right. Do you have any question for question number 1?
Ada.
All right. So for this kind of question, if you follow the steps given here, so first you need to carry out the Routh Hurwitz as usual for this transfer function or for these polynomials. And then when you find out there is a 0 in the first column, then only you choose either to use the epsilon method or also to reverse the coefficient. So always start with normal Routh Hurwitz, okay? So only use the first method whenever you find out there is a 0 in the first column. So for section 2, for some of them that have submitted the quiz, so what they did is that they straight away reverse the coefficient. I think they thought that this is already the case for 0 in the first column. But sometimes in exam, you don't know whether this is a case for 0 in the first column or not. So you need to carry out Routh Hurwitz as usual. Find out whether there is a 0 in the first column or not. Then only you continue with using epsilon method or using reverse coefficient method. Then you can continue calculating the determinant and also determine the stability for the transfer function. Okay, I hope you understand so far. And we continue for the next case, which is when you encounter 0 in an entire row. Okay. So let's say you are given a different transfer function as shown here. So here it's s to the power 5 as the highest power of the denominator. So you start your row with s to the power 5, followed by s to the power 4. And you substitute the boxes. You fill the boxes with the coefficient of the denominator alternatingly. So for the row S4 here, you can simplify 7 because it is the same factor for all of the values in the box. But you can also choose not to simplify. It will produce the same results. Okay. So after you calculate S4, you fill in the row S5 and S4. You need to calculate the row S3. So when you calculate row S3, you will see that you will get 0 for the entire row. So when you get 0 for the entire row, then you need to do some modification for the method. So the modification is quite tricky. So first you need to look at the row above S3. So you need to look at the row above the row that has all zeros in the entire row. So in this case, you need to look at S4. And then you need to form a new polynomial. So in this case, you form a polynomial P, Ps equals 1 s to the power 4 plus 6 s squared plus 8. So you start with s to the power 4, and then s to the power of 2, and then s to the power of 0 or nothing. Okay. And then the number in the box represent the coefficient of the new polynomial. So you get s to the power 4 plus 6s squared plus 8. After that, you need to differentiate the polynomial. So you need to find dp over ds. So this becomes 4s cubed plus 12s. Okay. And then after that, you use the coefficient for the differentiated polynomial as the values for the row S3. So you replace all 0 here with new value. So it becomes 4, 12, and 0. Because there is no more coefficient, you put 0. And then after that, you continue calculate row S2 as usual. So here you get 4, 12, and 0. So you can simplify, you can factorize 4, or you can choose not to factorize. It will produce the same results. And the row S square, we'll get 380, and S1 and S0. Okay, you continue calculate the determinant as usual. And then after that, you need to look at the sign changes in the first column. So here, in this case, in the first column here, there are no sign changes, all positive, meaning that the system is stable. Okay, okay, so we look at one more example. So let's say you are given this polynomial. So start with s to the power of 8. So your row also start with s power of 8 followed by s power of 7. And you fill the two top rows with the coefficient of the denominator or of this polynomial. Okay? And then you calculate S6 and the subsequent rows as usual. And then on row S3, suddenly you will get 0 for the entire row. So when you get 0, you need to look at the row above S3, which is S4, and you need to create a new polynomial. So in this case, the polynomial will start with 1 s power of 4 plus 3 s square plus 2 s power of 0 or plus 2 only. And then you need to differentiate ps. So you'll get 4s cubed plus 6s. And then you use this coefficient for your row S3 to replace the zeros. So it will become 4, 6, 0, and 0. And then you continue calculate row S2 and row S1, row S0 as usual. Okay, so you get these values, okay? And then you can determine the number of sign changes. So in this case, there are two sign changes, which is from S7 to S6. That's one sign change. And another one is from S6 to S5, another sign change. So only two sign changes, meaning that there are two poles on the right half plane of the S plane, and the system is unstable. All right, so during two session, they asked me about the meaning of this, okay? And I haven't found out yet, okay? So um, ignore this for this moment. I will explain more whenever I've found out about it, okay? All right, so that's it for the second method. So you can try answer quiz 10, question number 2. Okay, if you have any question, you can ask me. And okay, I give you around 10 minutes and then that's it for today's lecture. Okay, do you have any question for this question? All right, so most of the time, for example, like during final exam, you will encounter a question about Routh Hurwitz, but it will always, or not always, but it sometimes starts with asking you to simplify block diagram. Okay, so in this question, the block diagram is simple. Okay, only unity feedback. Sometimes it could be a combination of many boxes, many blocks, and you have a lot of summing junction or pick off point. And oftenly it will ask you to simplify block diagram first, and then asking you to carry out Routh Hurwitz. And yesterday you have learned about finding the suitable range of K for system stability. So sometimes the question asks you to find the range, or sometimes the question doesn't give you any value of K, but asking you to determine the stability of the system only. So there are a lot of questions, a lot of variety of questions, and most of the time it will requires you to simplify block diagram. Okay, so you need to um, make sure that you understand simplifying block diagram, how to simplify block diagram. And also for Routh Hurwitz, in subsequent lecture you will use Routh Hurwitz a lot of times. Okay, for next lecture, it involves sketching a graph of to determine the stability of a system, and you need to use Routh Hurwitz criterion to determine the range of certain values and to determine frequency of the system. And sometimes students forgot how to perform Routh Hurwitz, and Routh Hurwitz and simplifying block diagrams are the two key uh, methods for the subsequent lectures. So if you forgot, or if you do not understand these two topics, so it probably makes your life harder for AC. Okay, so I want you to revise for these two. Okay, even though it's not a big topic. All right, so if you have no question for question number 2, I want to give you a take home quiz. So this is an example of past year 2018. Sorry about this. So 2018 2019 semester 1. So this past year question basically asking you to describe how to use Routh Hurwitz to determine stability of 3 transfer function. So there are 3 cases that we have learned. So question A basically for normal case of Routh Hurwitz. Question B about the zero in the first column. And question C about zeros in entire row. So the question asks you to describe how. So maybe you can do not write a long essay. Okay, so just write a simple like step-by-step method. Maybe you can write first determine the coefficient of the denominator, for example, and the second one create the Routh Hurwitz table from S4 and S3 and fill the 2 rows, for example. Based on this question in 2018, 2019, most of the students couldn't describe the method. Okay, what they did is they simply calculate without describing. So the question asks you to describe. So if you simply calculate, you only get half marks. Okay, so this question is actually very easy, but most students only, some of them only knows how to do question A but don't know how to do question B and C, because maybe they don't understand the method. Okay, because some of them confused about putting epsilon, for example, and some of them don't know when to you find the polynomial and differentiate. Okay, so the same due date, Sunday 11:59 p.m. 21st June. Oh, okay. So submit quiz number 9 and quiz number 10, and also take home quiz. Okay. All right, that's all for today's lecture. And for those who came late, sorry about that. And any question, you can just WhatsApp me or ask directly to me. Okay. All right. That's all for today's lecture. Thank you. Assalamualaikum.
Salam.
Waalaikumsalam.